Hello, 8th graders. It's Tuesday, April 7th, and we're going to continue our work with real functions, particularly with the logarithmic and exponential equations. Some of these problems, they really do start getting challenging, as you can see right here at this particular example problem. This one here, there's only one problem, like problem 222, but it's such a good problem, and I want you to try to solve that for yourself. But use these notes to help you out with this. As you're taking a look-see at this kind of problem, understand that you can take a logarithm on both sides of an equation to make this thing work. Since I have log base 3, it's pretty clear I want to do log base 3. So I'm going to write log base 3 of x to the power of whatever log base 3 of x squared is, which is just wacky, isn't it? But that's okay. All right, and then I'm over here on the right. I'm going to write log base 3 of 1/9 x to the 5th. Okay, now at first blush you may look at that and say, well, how's that helping? Legit question. Now, but here's the thing. Anytime I have a logarithmic equation, I can actually fly over the exponent, when I'm taking log of some amount, I can fly that exponent over, and now I've got log base 3 of x squared times log base 3 of just the x. Hey, where did x's exponent go? Well, that was this thing right up here, see? I flew it over. And now I have this expression. Meantime, what about the right-hand side of this? Well, I don't have to do anything with it just yet, but I would let you know in advance here that where I am going to go with this is that I'm going to use my rules of multiplication here. So that okay, so power rule, it flies over. Log, remember how this works here. When I say log of a times b, I can rewrite that as log of a plus log of b. So with that means, think about how I can do that here. I can write log base 1/3, of 1/9 plus log base 3 of x to the 5th. I'll get back to that in a second, but hopefully you can see right now where I'm going to wind up going with this. In the meantime here, now I've got this, again, I'm actually going to fly over again. Isn't that funny? With this exponent right here, I'm now going to write 2 times, I'm going to try to keep the colors here, so hopefully it makes sense for you. So now I've got 2 times log base 3 of x times log base 3 of x equals, and meantime over here, well, you know what? I know what this is. I know 1/9 is actually 3 to the power of -2, right? Hold that thought. And then I still have log base 3 of x to the 5th over here. Fine. Alrighty. So what I can do with this, of course, is I could say, wait a second, this is going to be 2 times log base 3 of x. Since it's that thing times each other twice, I'm just going to say that's that value square. Now, in the meantime here, log base 3 of 3 power -2, I could rewrite that as -2 times log base 3 of 3. And log base 3 of 3, of course, that cancels out. This is basically going to be 1. So I wind up with just simply a -2 right here, you understand? All right. And then back over here to this. Let's do this. I'll fly this over. I'll say 5 times log base 3 of x, which doesn't seem to help me too much here. Other than the fact now I've got log base 3 of x on both sides of this. So fun thing I'm going to do with this is I'm now going to substitute. I'm going to let y equal log base 3 of x. And now I've got a quadratic equation that looks like 2y squared equals -2 plus 5y. See what I've done here? This is now y, this is now y. And now I've got, I'm going to write it over here. I'm drifting down into exercise 218, spacing it and playing this too well, I guess. I can write 2y squared minus 5y plus 2 equals 0. See where I'm going with this now? I can factor this. That's right. I know it's going to be 2y use your factoring techniques, please. And oopsie, sorry, that's got to be a -2. This can be -1. So I got 2y minus 1 times y minus 2 equals 0. And I go to solve this, of course, because 2y minus 1 equals 0. Okay, that means y is equal to a half, and y is equal to 2. What was y? It was log base 3 of x. So if log base 3 of x equals 1/2, think about how you could solve that. Anytime you've got a logarithmic expression like this, you could just say 3 to the power 1/2 equals x. And 3 to the power 1/2, of course, that just means the square root of 3. That's one of your x's. And the other one here is going to be log base 3 of x equals 2. So that's going to be 3 squared equals x, which will just be 9. So there's my solution set for this problem. Crazy, huh? Yeah, my solution set is just simply the square root of 3 and 9. They both check out. Feel free to calculate them with a calculator if you're not sure. As you go to do the rest of these, as you go to do exercise 218, for instance, here, you hopefully will notice that that these problems, as weird as these look, you can see that these will still actually be the same bases. I could write 400ths, of course. 400ths means this, right? 4 over 100. Oh, wait a second. That reduces to 1/25th. And 1/25th, of course, is a nice power of 5 because it's 5 to the power -2. So go ahead and solve this as 5 to the power of -2 to the power of x plus 2. Use your power rules. And voila, you'll have a nice little equation here because you'll have -2x minus 4 equals x because you've got the same bases on both sides with no addition of any sort. It's pretty easy to solve by now to find that value for x. And you'll do a similar thing with some of these others here. With this 9, of course, you could re-express that as powers of 3. What to do about that 240 here? Well, again, one thing before you express it as a some power of 3, know that y, if you substitute that for 9 power of x, you can absolutely get away with that because this problem here, that 9 to the power of x plus 2 means 9 to the x times 9 squared. So if you're writing that like this, but now you're going to substitute for y, now it's pretty easy to see. Y times 81 will equal 240 plus y, and now hopefully you see how you can solve that problem. The rest of these, again, there's nice little hints available for you. Just go ahead and work with powers of 2. Again, for this one, you're encouraged to substitute y for 2 to the power of x. So when you say 2 power 2x, you could just call that 2 to the x all getting squared, which now if you're substituting for y, this becomes y squared right here. And then go ahead and I'll let you figure out the rest of this portion right here, but you can again see the same equation solving techniques that I used before. 222, this is the one that is just like the sample problem I gave. See, instead of log base 3, now it's log base 2. Hopefully you see that. And as you go to do exercise 223, I'll go ahead and talk you through this one here. As you do this problem, it says what's the largest positive integer of n such that n to the power 200 is still less than 5 to the 300th. No, don't try using a calculator. That's crazy. You'll get something nutty. Instead, just do this. Understand that you could just rewrite this as log. You just take it as log base 5 of n to the 200th and say that that's less than 5. Oops, sorry, I forgot to write log. Haha. Sorry, log base 5 of 5 to the 300th. Of course, as you're going to do this, log base 5 of 5. If I rewrite this as 300 times log base 5 of 5. Log base 5 of 5 is just 1. This is just 300 times 1 is just 300, you understand. And meantime, over here on the left, same kind of thing happens here, except didn't go away. I just have 200 times log base 5 of n. And now if I go to divide each side by 200, I've got log base 5 of n. If I divide by 200, like so. Oh, that's just going to cancel. I'll just have 3 over 2. Log base 5 of n is less than 3 over 2, which as a logarithmic equation, let me rewrite it down here, log base 5 of n, if that's less than 3/2, what this is basically saying, of course, is that 5 to the power of 3/2 here, that n is going to be less than that amount. Now, you notice with the hint over here, it says, hey, you can use order, what we know about monotonicity. If n is less than 5 to the power 3/2, I should be able to square both sides. And now it should still hold. The order should still hold, like we learned in 7th grade. That n squared has got to be less than 5 cubed. 5 cubed, of course, is 125. So if my number squared has to be less than 125, we can see here that if n equals 11, then n squared would be 121. If n equals 12, n squared is 144. So pretty clearly, if n squared is less than 125, the largest value of n could be has got to be the 11. It can't be the 12. You understand? So that's what we'll conclude. We'll say the largest possible value for n has got to be 11. See? And then we saved ourselves, from trying to figure out the results of a calculator giving very, very large numbers in scientific notation. All right. So hopefully you're able to complete those exercises now up through 223. Email me if you have any questions. Schoology's been very, very slow to relay its messages that people send through Schoology Message. So please email me your messages. Press the like button on my YouTube channel. Just kidding, I don't have a YouTube channel. But I will see you in just a couple of days. Be good for your parents. Talk to you later. Bye now.